Hi everyone, the question is the number of real values of x at which the function f of x, which has been presented in form of a determinant, is not differentiable is. So here you must already be aware. If not, you can easily expand this determinant as a minus b multiplied by b minus c multiplied by c minus a. And if you see carefully, x square is essentially mod x square only. X minus 1 whole square is mod of x minus 1 square only. X minus 2 whole square similarly is mod of x minus 2 square. Yep. So comparing the two, you can easily see that f of x is essentially what? It is mod x minus mod of x minus 1, mod of x minus 1 minus mod of x minus 2, mod of x minus 2 minus mod of x, based on the same understanding. And what we want is the number of real values of x at which the function f of x is not differentiable. Mod doesn't create any discontinuity as such. So fx is continuous everywhere because discontinuity doesn't occur because of mod as such. Yeah. So my suspicious points will be what? My suspicious points will be x equal to 0, x equal to 1 and x equal to 2. Yep. Because there fx can possibly be non-differentiable. Yeah. So first I'll try to write fx a bit elaborately, in the sense I'll say when x is less than 0, when x is between 0 and 1, you can put equality both ways, doesn't matter. Why? Because it is continuous anyway. X is between 1 and 2 and x is greater than equal to 2. Yeah. So when x is less than equal to 0, all of them will open with minus sign. So what you have is minus x, minus minus will become plus, so you have plus x minus 1. Yeah. Times 1 minus x plus x minus 2 times 2 minus x plus x is what you'll get, because every term, every mod will open with minus sign. So what you get is minus 1 times minus 1 times 2. So what you get is 2. What about here? Here mod x will open with plus sign and mod of x minus 1 and mod of x minus 2 will open with minus sign. So you have x, since this will open with minus sign, plus x minus 1. Here both of them will open with minus sign, so 1 minus x plus x minus 2, and here this will open with minus sign and this with plus sign only, so 2 minus x minus x. Yeah, so what you essentially get is 2x minus 1, this essentially is minus 1, and this essentially is this becomes essentially 2 minus 2x, which with when multiplied by minus 1 you get what? 2x minus 2 multiplied by 2x minus 1. So essentially, if you see carefully, maybe we can keep some gap here. So what you essentially get here is you get 4x square minus 6x, I hope we are doing calculation right, plus 2. Now what about when x is between 1 and 2? Only mod of x minus 2 will open with minus sign, rest 2 will open with plus sign. So here you have x minus x plus 1 times, this will open with minus sign. So what you get is plus x minus 2, and here this will open with minus sign and this with plus sign, so you have this essentially. So if you see carefully, 1 times you have 2x minus 3 multiplied by you have 2 minus 2x. So what you have essentially is minus 4x square plus 6x plus 4x plus 10x. I hope we are doing right. Minus 6, the calculation part, I hope. Yeah. And when x is greater than or equal to 2, all open with plus sign. So you have what? You have 1 multiplied by 1 multiplied by minus 2. So what you have is minus 2 here. So here you get minus 2, here you get 2, and in between you get some expressions in x. Yeah. So and they are supposed to be continuous. You can check it out. At 0 you are getting 2, makes sense. At 1 you are getting 0. At 1 you are getting 0, makes sense. Yeah. At 2 you should be getting here minus 2. So you get what? Minus 16 plus 20 minus 6. Yep, makes sense. So fx, mod anyway doesn't disturb the continuity part. Yeah. So our suspicious points for non-differentiability are 0, 1 and 2. So I'll just go for left hand derivative and right hand derivative. So at x equal to 0, what about left hand derivative? It is 0, because it is supposed to be a constant function for x less than equal to 0. What about right hand derivative? You differentiate it and put x to be 0. So you get what? Minus 6. So at x equal to 0, it is not differentiable, and hence it will be part of our answer. Yeah, not differentiable. Here we want the number of real values of x at which this function is not differentiable. So what about x equal to 1? What about left hand derivative? Here, given that we have already ensured that at x equal to 0, at x equal to 1, at x equal to 2, fx is continuous. That's why we are just directly differentiating respective expressions of fx to get left hand derivative and right hand derivative. So here you get what? You differentiate and put x to be 1. So you get what? 8 minus 6, you get 2. What about right hand derivative? You get minus 8 plus 10, you get 2. Interesting. At x equal to 1, fx is differentiable. Yeah. So that means it is a very good question, in my opinion. So what about right hand derivative here? It's 0. Why? Because for x greater than equal to 0, function is constant. And what about left hand derivative? So you get what? You get minus 8x plus 10, and you put x to be what? X to be 2. So you get what? Minus 6. Yeah, I hope we are doing right. So again, at x equal to 2, function is not differentiable. So at x equal to 0 and at x equal to 2, function is not differentiable. That means number of real values of x at which this function is not differentiable is 2. C is the answer. Thanks for listening.